Let's briefly talk about buffer overflow in X86. So in X86, stack goes from high address to low address. Let's say we have a program with two functions. When function 1 is called, we have the parameters here, we have the return address, we have the base pointer. The return address points to function 2 because after function 1 is executed, the next line of code is function 2. And base pointer uses an index, and it doesn't matter in this case. And the following memory region belongs to local variables of function 1. What if function 1 is vulnerable? Let's say in function 1 we have a buffer of 128 bytes, and we take input of 1024 bytes. It's obviously a buffer overflow problem. If we fill this area with A of 128 bytes of A, and we add 4 more bytes of our input of A, we're gonna cover EBP with A. What if we put 4 more bytes of A on top of this? We're gonna cover the return address with A. So what if we replace the 4 bytes of A to 4 bytes of address? If we replace the return address with this address, after function 1 is called, it's not gonna execute function 2. The program will jump to this address. But if we put our payload on top of those inputs, we put our payload here. All we have to do is figure out how to make return address jumps to our payload to execute our arbitrary code. So how are you going to do it? Remember, when return address is called, the ESP becomes ESP plus 4. So initially it points to here. When this instruction is called, the ESP points to here. So if we made the return address, this address points to jump ESP. So after function 1, the vulnerable function is executed, it's going to jump to your payload, right? So people may ask, why don't you just hard code the address of the payload into your exploit? Well, in different operating systems, the address can be different. It might be F4567A, or it's going to be F67A. So you can't predict this address in different environments. So people use piece of code, jump ESP, within different libraries that they are dynamically linked to each other, and made the program execute the payload. The payload will be theoretically 128 bytes plus 4 for the EBP, and the return address of jump ESP, and then that's your payload. So I hope this diagram makes you understand the buffer overflow problem in the SS netlib better, and I see you in the next video.